Hi and Assalamualaikum. I am AMALINA. So today our group are going to present our final database project, which is bus ticketing system. So this project aims to develop a bus ticketing system, a digital solution that streamlines the booking and management of bus tickets for both passengers and bus companies. So we found 3 objectives from this project, which is the first one is to design and implement a comprehensive bus ticketing system that streamlines the booking and management of bus tickets. The second one is to create a user-friendly interface that enables passengers to easily search, book, claim refund and manage their bus tickets. And the last one is to develop a robust backend system that allows bus companies to efficiently manage their fleet, schedules and customer data. So here, I provide only 2 examples of SQL of TDL, but actually we had 7 tables, including ticket, table ticket, table modification ticket, table history ticket, table bus, table payment, table passenger and table driver. But I only put 2 here just to explain a bit. Okay, the first one, this is how we create a table bus. We must create here and create the table bus name. The plate number, company name, company address, company phone number, type, capacity, driver ID is the attribute name for the table. The varchar here and the int is the data type, and the number that you see on the inside the bracket is the size of the data type. So I will explain each one of these. So the first one is primary key. Primary key usually enforce entity integrity. The primary key column never accept empty or null or duplicate value. So if you guys can see, they have 2 here, not null and null. I will explain about the not null first. So the not null is enforce a column not to accept empty value, while the null is the vice versa. The foreign key here is references driver to the driver table, which we only take the driver ID from the driver table. So the foreign key may accept null or has valid value from reference table, the same as this attribute and the data type, but the difference is the check. The check is to ensure that a column has a range of value or specific data. Like this one, they have specific data like cash and online only. So whatever data that different from these 2 the data cannot be accepted. So thank you.
My name is Arfa Nadia. For your information, our title is the bus ticketing system. Today I will explain about the scope and the problem statement. I will give the 2 examples of the scope, which is for the passenger and the bus company. It has a few scope under passenger and bus company, which is for passenger, user registration and login, bus schedule and route search, ticket booking and payment, ticket management and cancellation, and lastly, passenger profile and reservation history. And for the bus company, company and fleet management, schedule and route management, ticket sales and inventory tracking, passenger data management and reporting and analytics. And for problem statement, the first one is, the current manual booking system for bus ticket is taking up a lot of time and lead to error and mistake, often leading to frustration among passengers. Second, bus company face challenges in effectively managing their inventory, making bus schedule and collecting customer data, which hampers their ability to provide a seamless service. And lastly, passengers lack a centralized platform to compare bus schedule, price and availability, making it difficult to plan their journey efficiently.
My name is AMIRA and I'm going to talk about the bus ticketing system for our ERD diagrams. So as we can see in the ERD diagrams, there are 7 tables, which are ticket, passengers, ticket history, bus, driver, ticket modification and also payments. For the ticket table, the entities that stores is the detail of each ticket, which includes the ticket ID, destination, price, seat number, departure time, arrival time, durations, gate, the passenger ID, purchase date and also the company name. Primary key for this table is ticket ID, and the foreign key for this table is passenger ID, which connects with the passenger table. Next, we have the passenger tables. The entity holds the personal information of each passenger, such as passenger ID, first name, last name, phone number, email, ticket ID and also payment ID. The primary key for this table is passenger ID, and the foreign key to this table, there are 2 foreign keys, which are ticket ID and also payment ID. The ticket ID links with each passenger with their respective tickets, which also known as one-to-one relationship with the ticket table, and the payment ID holds one-to-one relationship with the payment table as well, because one passenger holds one ticket. And then we go to the payment table. As you can see, the entities stored in these tables are payment ID, ticket ID, and also payment type. The primary key for this table is payment ID, and the foreign key for this table is ticket ID. Next is the ticket modification tickets. And the primary key for this table is a composite key that consists of ticket ID and also passenger ID. The ticket modification has a foreign key relationship with the ticket and also the passenger's table. The table entity connects each modification to the respondent's ticket and also the passenger's table. Next, we go to the driver's table. The driver table consists of driver ID, first name, last name, and also the driver's phone number. The primary key for this table is driver's ID. And then we have the bus table. The bus table consists of plate number, company name, company address, company phone number, type, capacity, and also the driver ID. The primary key for this table is the plate number, and the bus entity has a foreign key which relationship with the driver entity, which links to the bus to one bus is consists for the specific driver. Last, we have the ticket history table that holds ticket ID, purchase date, company name, price, and also status. The table has a foreign key, which are ticket ID. Ticket ID links with the ticket entity, and the passenger ID links with the passenger entity.
Assalamualaikum. My name is FARIHA AFIQAH, and today I will show you the example of 2RA and SQL of DML. The first one, we use insert. Insert is used to insert the values into the table, which the table that we use are passenger. So we use these values to insert the values into the passenger table. As you can see here, this is the example of the SQL. And then the next one, we use update. Update is used to modify the current existing table into the new data. So for update, we use for the existing phone number in case the driver wants to change the phone number. So we use update to change the existing data into the new one. So this is the example of the SQL of update. Okay, and then next one, I will show you the example of 2RA and SQL of single row and multiple row subquery. The first one is single row subquery by using one table. So the table that I use is ticket, and this is the RA, which I wanted to show ticket ID by using passenger ID who have the passenger ID where passenger ID is 10025. So this is the expected SQL. This is the SQL and the results. And the next one for multiple row subquery, I'm using multiple row subquery but using one table. So this is the RA that I use, which I wanted to show which passenger that have first name Sophia and including last name Sophia. So as you can see, this the output will show the results will show passenger ID who have first name Sophia and last name Sophia. So that's all from the bus ticketing system team. I hope that people who wants to create a new ticketing system bus team can use our system database, and I think this project is achieve all of the objective, and that's all from us. Thank you very much.